Okay, so I wish all of you, all the participants, a very good morning. Hope all of you are doing good. Mm, and you're enjoying the program. I am Dr. Diptendu Sinha Roy. I think I came on the first day in the second session to introduce my friend and my colleague, Dr. Somen Maulik. So hope you enjoyed the lectures. We had to have a slight reshuffling of the schedule due to the, last minute plan change of Professor Gautam Saha, who had given yesterday's session, the last session yesterday. So today I'll be, discussing, the basics of Hadoop and how Hadoop can be used gainfully for leveraging a number of, requirements, particularly associated with the storage of IoT data, and then that is where we'll stop. So I'll be coming frequently. I have actually 4 lectures, but because of this last moment schedule change, so some of the topics had become a little bit, jumbled up here and there. So anyway, I'll try my best to keep the flow. So if you have observed, I'll just because I had been involved in planning out this program. So I'll just introduce I'll just brief you about the motivation of this particular course, so and why we named it. So usually it was Internet of Things, but we build the theme as Internet of Things from data collection, data acquisition to storage and analytics. So that is why primarily 3 of us and at NIT Meghalaya will be covering these courses, various aspects of Internet of Things and how we can do more or less research. What direction. So that is the primary goal, because this is a faculty development program, and we would like that we get some help from all of you in the long run. If you feel interested, you can collaboratively do something meaningful and in the long term. Okay, so with that goal, we named the theme of this course as from data acquisition to storage and finally analytics. So the data acquisition part, the different protocols, and I'm sure Dr. Somen Maulik must have briefed you, and he must have also shown you, certain microcontroller based systems. That is what I'm here. So yesterday's Professor Gautam Saha must have also discussed. I did not find time to go through what he actually presented, could not attend it. However, from the name, what I understood is that, how to architect an Internet of Things, okay, based on different, different models for architecting so the distributed, because cloud gives you a centralized view of data storage, which particularly for real-time IoT applications becomes very difficult for storage and finally analytics and giving the actuation back to the IoT system. So for computing and mobile edge computing, so different names. I'm sure he must have briefed you on this. So out of my 4 sessions today, I'll be taking 3. So today we'll be discussing more on the storage side, okay, and how Hadoop can be essentially used for this purpose. So I'll speak for some time the basic principles, as the first lectures has been titled. So basics of Hadoop, and the goal of that session would be, because many of you must be already acquainted with Hadoop and how the principles work, and then based on that, what we discuss, then I'll have some demonstrations which will be supported by my PhD scholar who will be graduating very soon, hopefully. So he'll show you some demonstrations on and we'll also by the end of this today's sessions, we'll also try to summarize to you at what level Hadoop performance can also be optimized, so at different levels. So I'll brief you. So back and forth, so we'll be switching shifts. Okay, so I'll tell some basics and we'll start with the installation. So one thing which might happen is that we might not be able to exactly break at the boundaries. So however, boundaries means the session 1 ends and the topic 1 ends. It might not happen exactly like that. So in that case, we'll respect the timelines, because there may be many participants who might have certain problems in joining the first session. So they might be expecting, they might have kept some time to attend the second session at least. So if we delay it too much, so that might cause a lot of inconvenience to them, and their plannings might go haywire. So we'll respect the timelines. So wherever we stop, we pick up from there. Okay. So our goal would rather be to cover whatever ground we cover during these 3 sessions today. So to consolidate on that, to have some, a proper discussion, it would be nice if we can have some discussions, and particularly in how we can leverage the understandings, at least the tools and all. So I will be happy to help you, support you, at least to start with. So this point had to be clarified, and then probably in the next session I will not be available for the question and answer. So if you can have the question and answers somewhere during the break times, okay, or maybe during the second session. Okay, so if you have any questions, that would be great. I will not be available during the hands-on session, which my PhD scholar Mr. Mir Wajahat Hussain will be coming. Mir, you can just come in so that I introduce you formally. So you can just switch on your video once. People should be aware. So whenever you take over the stage, then there should not be any confusion. Okay, so Mir is currently sitting in Srinagar. So hope his internet connection moves on flawlessly. There might be some issues. We also have some backup videos. So if things are difficult, so we'll show you some demonstrations, pre-recorded demonstrations. So that I leave it to him, how we will conduct. Okay, Mir, that's fine. You can mute yourself, and then we'll start. Okay. Right. So I just share my screen. Mir, you can mute yourself now.
Yes, sir.
I'll call you. Yeah. When required, I'll call you.
Okay, sir.
So what I want to do, my screen is visible, na? Not yet.
It's visible, sir.
Okay. So this presentation will be for the first and second sessions combined. So here, somewhere in between this, while presenting this, I will come to a point where I'll just tell you how this connects to how IoT data which are collected from across the different sensors, that can be connected to Hadoop. And usually, just before moving on to the presentation, just one more thing: most of these functionalities which we'll be discussing right now, so they are already implemented in cloud. So it is up to the cloud providers who already have these facilities, who already have these mechanisms and workflows, softwares for doing workflows and all. So they are inbuilt. However, it's very important for us to understand, because for every time it's not possible for us to for a very small these things IoT applications to take cloud services, which might not be prudent also, okay, economically, in terms of the response times required for those applications. So it will be like firing a gunshot to kill a mosquito or something like that. So not required. So in that case, we can build it in our local systems, itself, Hadoop setup, and which can function for these big data sort of scenarios. Okay, so with this introduction, I'll be starting the session. Okay, so what I have justified till now is where and how Hadoop fits in IoT. So in an IoT, we have already gone through the sessions where data acquisition techniques have been elaborately discussed, at least some concrete examples, and in general, the different use cases must surely have been covered. So you have to understand that nowadays we are in the age of big data. It's obvious. We use Facebooks at least. So we have so many Google accounts, so many, all bank transactions, everything is digitized. So everything is available in the digital platform. I think it's better I switch off my video at this point in time so that I can preserve some bandwidth, my audio quality remains intact. Yeah. Okay. So so data is aplenty. They come from different sensors which are placed across the different places, across cities. In every aspect of our day-to-day life, we have sensors. The mobile phones have many sensors, at least 15-20 sensors, depending on what type of what high-end, to the end at which, to the level of sophistication your mobile phone has. So 15, 20, 25, even 30 is sometimes okay. So then we have, I mean, the cities and all, they have CCTV cameras at different places. So all of them generate huge volumes of data, okay, which needs to be processed. And finally, I mean, based on the processing, it might give you certain directions as to how analytics can be done for achieving some meaningful goals. But before that, the one of the primary challenges that comes into mind is how to store them, because these applications, for example, applications like IoT applications like smart grid, smart home, even for example a smart home IoT. I hope you, I mean, some introduction you already have. These are very common sense things. Smart home is a smart home application is still a localized application, in the sense that you can put the server somewhere within the home. But applications like smart homes, smart cities, which are physically distributed, geographically distributed. Okay, so a big question comes, where do we keep the data? So there are two primary possibilities. One possibility is that wherever you have the CCTV cameras, you can store them, store those data corresponding to that particular CCTV camera. Just I'm taking an example, it can be any sensor. So to store that locally, okay. So it has its advantage. Advantage is the storage is, I mean, the technology is already available. I mean, at least I mean, it was available even 20 years back, locally store as much, I mean, quite voluminous data. Challenge comes when we want to do a, so similarly in a smart city kind of a scenario where sensors are well distributed, geo distributed across a city or across a big geographical area. In that case, the challenge arises is that when we want to um, do some analytics, we need the data. So if so in that case where all the data are locally stored, so at the storing point, the challenge is not there. The challenge comes when we try to compute with that data. Okay, so in that case we have to copy data from different servers across the different locations within the city or maybe even wider space, and then the network delays are very unpredictable. Okay, it depends on many factors, primary to which is the traffic in the network. So congestion in the network, there is puts you in a circumstance where in a particular scenario where you can't guarantee whether the data that you're receiving is of any use to you or not. Okay, that the deadlines are being met or not. So okay, so if you are talking, I mean, thinking of conceiving a scenario where you want to pinpoint an event which has occurred. So in a case where you are storing it distributed across the city, so then what you find data at the central location now might actually be a 2 minutes old data. I mean, because I mean that may vary. That is the point which I'm bringing. So very difficult case. So in cloud computing, using such techniques, and I mean in general the distributed paradigms and also, there has been technologies which has evolved, particularly the, I mean, mechanisms for distributed consensus and time stamping being a very simple way. So even the data is received late, but the database remains consistent in terms of the time. They are sorted and kept because timestamps are there. So similarly, they can be geotagged. Okay, so they can use GPS information and put them, and then in that case, as a particular application can actually pinpoint which data stream corresponds to which specific geolocation. So the technologies have been there. However, to do analytics, I mean, so these three, this brings us to a case where we can appreciate the different views of big data. So this everybody knows, so I'm not going into the details. That this volume and velocity and all. So velocity corresponds to speed, volume corresponds to, of course, the something is wrong. Okay, volume corresponds to the amount of data. I think this animated slide somewhere it got stuck. Okay, it works fine now. Okay, so then why Hadoop for this particular scenario? So we touched upon this IoT scenario. We also discussed that usually these are implemented in the cloud, Hadoop in its naive form, or there are so many, I mean, usually the open source version of Hadoop, the Apache Hadoop, very widely used. However, they have to be tuned and maintained, and also there are different companies have come up with their own distributions of licensed versions of the same open source Apache Hadoop, but with their own dashboards and all, so that they market it as a product. And cloud providers, so they have usually tie-ups with those. So these are all taken care of the cloud. What I impressed upon is that even if the cloud provider may give all these services, it is good for us to know, because in our scenario, if we want to develop a test bed, or if you want to develop an emulation platform, so it's better, it's not that difficult with simple Linux programming languages and Linux administration basic idea of that. You can actually set up a system and tune it. Okay, so those demonstrations also will be there later on in the section, but I'll just try to connect them and then hand over to the demonstrator part. Okay. So now the main question which comes is that, so just 1 minute before I go, just maybe I'll go a bit forward to show you this, that for doing all this, I mean, data which are coming across from different types of sensors, different types of data. So Hadoop basically is a twofold, provides you two primary services. It's the way in which it stores the data. Okay, the file system of Hadoop, which is very special, unlike the FAT32 in Windows and this thing. It's a distributed file system. Those specialties will be pointed out later on, and it's about the MapReduce programming paradigm. Okay, which was shown here in this slide. Here. So this shows the distributed storage part. So this actually, to do this distributed storage, Hadoop has its own very specific file system, which is called the Hadoop distributed file system, and it has a programming paradigm which is unlike the traditional way of programming. So the traditional way of programming, I'm talking of, before this RMI, RPC, this remote procedure calls based paradigm was, there, did not become so popular. Till that time, the idea of computation was that you have to have the sensors, can get the data, and over a network send all those data, but the data has to be available for computation at the computer, processor's side. So it has to come. Okay, so like if you don't have the entire data in your hard disk, the processor doesn't have it in its secondary memory, so it will not be able to start executing that. So this imposed severe restrictions on the volume of data which a program could handle. Okay, so over a period of time, maybe 3 decades back, people researched a lot how this restriction can be overcome. The restriction is that a program can keep on working with the data, which is, primary of 2 aspects. One aspect is that which cannot be completely held within the storage. So distributed storage technologies came up over a network, and then the second aspect of it was how to handle data which are continuously getting populated, so streaming data. So they can be handled as of now, but then why Hadoop? From this picture. So this, of course, this is general big data scenario. I'll just go back so that allow the slides to come. I was not allowing it to come completely. Okay, so this distributed data, the meaning, what it conveys is that there are, as I already mentioned, geographically at distributed locations, there are different storage disks. Okay, the data is stored in those disks in such a manner that some primary characteristics are fulfilled. Okay, for example, anonymity is mentioned. Transparency, we call it. Yeah, transparency. So a user who has some data which is stored in a distributed file system or a distributed storage knows that my data is somewhere within this, even if he knows that there are a number of storage servers there, knows my data is there somewhere, but out of these 7 or 10 or whatever number of storage disks are there, although he's able to access the data, but he'll not be able to pinpoint as to which disk actually his data is coming. So this is called access transparency. So for the users, this transparency is there. Similarly, for better reliability of the data, many times replications and all were there. Had to be incorporated because one of these disks might fail, and accordingly, all those technologies, if you have this RAIDing concepts, RAID 1, RAID 2, RAID 3, and so forth. So these concepts came in. These were there at that point in time, where and of course, the computation engine which will be shown here, this computational engine works on data which is there. It doesn't matter that if a data in part comes from this particular storage, another part of the data comes from this storage, it works seamlessly. So uh, this was like more or less the paradigm, even in the early days of distributed computing. Okay. uh, what Hadoop did was that, I mean, this not just Hadoop is the name of more or less a project. Okay, but this way of computing, okay, this specific way of handling big data, which started with Google's 2004 paper, white paper, which proposed the, sorry, the Google Big Table. Okay, Big Table, I think that was the name they used. So accordingly, they proposed a Google file system. But then this remained with Google as a, I mean, a concept only. Did not go. I mean, did not boom. The boom came with Yahoo. I think a year or two later, where they actually implemented this concept in book, the Big Table, and the storage part of it, and then came the MapReduce. Yeah, MapReduce, this concept, so that we'll see in details. Okay, so it was still not a patented concept, it was just a concept. So that was implemented later on by somebody in Yahoo, maybe 2 years down the line, with an implementation, and which was made later on to an open source project under this Apache, as an open source Apache project, and that was given the name Hadoop. So we're not going into the history of it, not necessary. So basically it draws all its inspiration from this, again, this Google's papers, and then implementation, which allows a program not to or a computation, a program which is running in a particular CPU, let us call a server, okay, to work on data which is not necessarily stored in its local disk. Okay, so that was possible by these remote procedure calls and remote methods which could be invoked. Okay, so with the advent of Java and then different advancements in this area, this was made possible. So Hadoop was initially written in Java, okay, where they could actually harness this particular aspect. Okay, so the computation, instead of that pulling the data from all across different places, all across the different servers which are all connected to some way or the other different sensors, and pulling it to a local storage, which makes it very, very slow. Instead of that, it was like remotely invoking a method from this place to a server which is somewhere else, and then collecting them back. So that is the essence of MapReduce. So map part was this distribution of computation, okay, using by invoking certain remotely invoking certain methods where the datas are. So basically the goal was to co-locate computation and data. Okay, so computation and data. This figure, this virtual boundary which shows, is a conceptual boundary only. Okay, so what it doesn't show is the physical servers and the connection between this storage here and the computation here. So servers have both. So beyond this boundary, so this individual machine boundary was actually blurred by this RMI concept which came along with Java, and then it could be built. So basically distributing the job, the goal was to co-locate computation and data. Why it was done? To give a better, far superior response time. Okay, fine. So with that, so in order to pull this data from different types of sensors, different types of different data types, different databases, which, so accordingly Hadoop, although the basically it has those two components, the file system, very new, very inventive at that point in time, and the MapReduce concept. But in order to build an actual application, it would also require a number of other tools to feed all those different types of data to the and to get them stored as HDFS. Okay, so that part, so these are all called ecosystem tools, because they combinedly they form an entire ecosystem. So like Pig for scripting, and Mahout became popular quite later. Pig was there from the I mean, much earlier than Mahood came, when machine learning components were there. I'm sure something other else is going on right now. So HBase for NoSQL databases. So many different types of tools were there. So the core part still remains of Hadoop, this blue shaded area. Okay, the distributed processing with the MapReduce, which is a trademark. I mean, computation and technology. It's used very widely, but the principle is well understood. Okay, and the Hadoop distributed file system. Okay, so these aspects of it theoretically also will go and see later on. Okay, but I think I'll also show you some essential parts which are the main challenges during installation of Hadoop. We'll start right from there, and then we'll come back to the key. We have to know how a MapReduce program actually works. What are the different phases of it? Knowing that, how they pull data. So knowing those principles would allow us to go to the actual content of this, I mean, actual point of discussion of this session, which is basically how to optimize the performance of Hadoop using different techniques. So that is the reason why we'll go and see what are the steps of MapReduce program execution. Okay, so a bit of an introduction, then we'll maybe in 15 minutes from now or so, 15-20 minutes from now, we'll go and start the installation. We might that particular topic might not be ending at 11:30, but as I told you, we'll break on time and start on time. Okay, so now this slide basically shows the different actors within the Hadoop, conceptually, of course. So the different components of Hadoop, okay, abstract components. Okay, so you have number of servers here. Okay, so assuming that they are all these servers, this computation and data storage capacities are stored in some rack servers, in some racks. So we install Hadoop across all these racks. Okay, so as already discussed, so this Hadoop's main component is a distributed file system, which technically we call it Hadoop distributed file system, because there are many other distributed file systems also. There are some common characteristics of any distributed file system, like I told you, the access transparency, the location transparency. So all these transparencies are, I mean, default policies for any distributed file system. Okay, the Hadoop distributed file system is slightly different, so that we'll go on and see when we see the protocols and all. So coming up later, I'll not go into too much of details because that is not necessary at this point in time. Okay, so when we install Hadoop across so distributed file system, so this, let us say what this figure shows, these 3 racks, whatever storage are available to all these 3 racks collectively becomes a single address space for the Hadoop distributed file system. So that file system sees the sum total of all these address spaces as a single address space. Okay, so it can allow users to store their data as files, and later on, as we will see, I mean, they are, again, whatever data are stored based on user requests, they are not stored as a file per se. Okay, they are further broken down into components called blocks. Okay, so a single file is again broken down into multiple blocks, 2 blocks, 5 blocks, and n number of blocks. So that depends on the file size, of course. So these are all configurable things. Okay, so what should be a block size? So that can be configured. So this will be shown during installation, that demonstration part also, how we can do that. But now this, I mean, the sum total of your Hadoop, let us say, cluster will have a name node. Okay, so one of the primary components of I mean, a Hadoop cluster is that it has a name node, which we'll see later on, which will be like the source of all possible metadata which are stored here. Then whenever computation comes, right, and there are a number of data nodes also. Okay, right, so data nodes, as you can understand, so this shows a physical server, this shows a physical server. Okay, this shows a physical server, and a number of such physical servers are I mean, framed within a particular rack. So in that sense, it shows a cluster where rack 1 has rack 1, rack 2, rack 3, everybody, all of them have 5. I mean, the diagram is like that. It's not necessary it has to be like that, and numbers are immaterial. but n number of servers within it. So servers include computation and storage. Okay, so a data node is responsible for storing the data. So data are stored across all these data nodes, right? Then the name node is responsible for, see, now we already discussed, if a user wants to store a file, that file within the Hadoop distributed file system is not stored as a file per se. It is further broken down into blocks of equal sizes, and the block sizes, which I told you, is configurable. Okay, so a single file now will have a number of blocks, so forth, a number of blocks. How many blocks, that will depend on the file size itself, because the block size, after you configure it, it remains fixed. Okay, so now see, you're doing it for what purpose? So that based on the computation request, you can co-locate. Don't forget the goal. Performance can only be gained if you can reduce this time for pulling out data from one server to the other, because that happens over a network, which makes it very slow, unnecessarily increase the bandwidth of the system, of the buses. And if we increase the bandwidth utilization of the bus, then again the entire thing, the performance goes down, because more through a set of buses, if the bandwidth is utilization is kept low, then the performance can be still repeatable. I mean, it can be within limits. But if we cannot ensure that, if you unnecessarily keep on utilizing the bandwidth, that creates a lot of collisions, which makes all the transactions very slow over a network. Common sense. Okay, so now we have divided a file. So if there are 10 files now stored in this HDFS, so file 1 to file 10, and there might be possibly, I mean, just to give you an example, 300 blocks now. Now, who will, whenever a user requests for some data processing, some processing over a data, because you have broken a file and kept it at different locations, now it is the responsibility of Hadoop HDFS to find it also. Okay, so that finding out, I mean, to maintain all the listing services, I mean, like maintaining the tables, which file is broken into how many blocks, each block is location to which address, because all of these are, I mean, location, server, storage, everything will be accessed ultimately by addresses. So how that address mapping is done between the physical servers to the table which is maintained. So for that purpose, all these metadata are stored in the name node. So the data nodes are responsible for storing the actual data, not in the form of the file that the user wants, but after breaking those files into blocks. And we'll see now replication is done, so that will be, I think, covered later on. But you can understand, it's not that one file is broken down into, let us say, 4 blocks and we just place the 4 blocks. No, because these systems also are maintained for very high reliability. Okay, so always, or reliability as well as availability, means they should always be available. So it means that even if one of these data nodes goes down within a server, so somebody else could be able to, able to give that data. So how is it possible? It is possible only when a replica of the copies of these blocks are maintained somewhere else. So we actually, in that sense, we are storing the same blocks at many places. Okay, so the replication degree can, its default set to 3, but it can again be configured. Okay, it can be made 5, 4, so that 4, 5, so forth, depending on how much more reliability you want to add to your system. So more the degree of replication, more will be the reliability, but then you are also storing, spoiling a lot of storage space. So anyway, nothing comes for free, everything comes at the cost of the other. So if you want reliability, you pay the price in terms of the storage. So all this information, so if this block, this particular node suppose goes down, this data node goes down, so there should be a table within the name node, within the HDFS, which will try to find out that in data node 3, what were the different blocks corresponding to which file. So block number, file number, and which rack number. So all these addresses are maintained in a table. So those, where do we keep that? We keep them in the name node. So that is why we say that the name node is responsible for preserving all the metadata. So it's not the data themselves, not the files, but what is stored in the metadata are all details corresponding to files, where they are located, how many replications are there, at which locations, which servers those are available. So everything is maintained in the name node. So that is why if the name node goes down for whatever reason, you actually lose control of your entire Hadoop distributed file system. Okay, so that means all data is lost. Okay, so that is why there is also backup copy of the name node is kept, because see, any system can fail. So because we are taking so much of care, we are taking so much of care to to make sure that data is stored properly, and even if a failure occurs, recovery can be done. Still then, if you don't have a backup copy of the name node, so you don't have to have any of these data nodes to go down. Simply if your name node goes down, the system goes down. So that is why sometimes it's not, of course, mandatory to have a secondary name node, but usually it is kept, particularly for enterprise level systems. They do keep not just one, sometimes even two name nodes are kept. Okay, which are very costly in terms of the spaces which are provided, to the name node. Okay. However, although we are showing here 3 servers, it's not necessary that you can, in order to have a Hadoop install, you actually need 5 physical machines or 3 physical machines. It's not necessary. Even if you can do everything in your same system. Okay, but then of course at physical level you won't get all those benefits which performance benefits, because ultimately some of the buses which connects the processor of your laptop, suppose you install Hadoop in your laptop, a single machine, it also has a name node, it also has the data nodes, but then all those name nodes, data nodes, everything are using the same storage space. It is using your same hard disk. So it's just for it works fine, but it's an illusion that all these things are existing. You won't be able to what do you call that, draw upon the benefits which Hadoop provides with this. And we don't need it also, unless and until we are actually implementing some real services, real applications. Okay, so this I told you. And then job trackers and task trackers, I think it's better to leave it for now. It will be taken care of. We'll come back to it later. Okay, for performance, so what we have seen in terms of key components, Hadoop has distributed file system, Hadoop distributed file system. Primary characteristics endowed by it are the breaking up, the way it stores files by dividing them into blocks and all, which are again configurable, can be made different. And we have come across 2 terms, the primary 2 components. One is the name node, okay, so which stores all the metadata, and then we have the data nodes where actually the data blocks are stored. And in the name node, what metadata it stores all details of all those blocks. Which file is broken into how many blocks, those blocks are placed at how many locations, what is the replication degree, what are the addresses, all these details are stored in the name node. Okay, job tracker, task tracker, later point in time, if required, we'll come back and discuss. Okay, so I think better is the, okay, let me stop here at this point in time. Mir, if you are there, you can just start based on this discussion. You can just try to show the hands-on for this part. We'll discuss a bit about the key essential points in Hadoop installation. Once that is done, we'll come back and we'll take over from here. Okay.
Okay. Okay, sir.
Or at this point, if there are any questions, I can take. Okay, you can start. No issue. I'm pulling out my presentation, so you can share your screen and can start.
A very warm welcome to all the participants and my friends assembled here. Today I will show what are the steps for installation of Hadoop.
You may share your screen, Meet. We are not able to see your screen.
Yes,
Yeah, yeah.
so is it shared, sir?
Yeah, yeah, yes.
Is it fine?
Yeah, yeah,
Uh,
visible. Please
okay,
go ahead.
okay, sir. Okay. So there are various prerequisites for Hadoop installation. So before going through all of these, let me ask a question: why is Hadoop essential? As Sir has already pointed out, because of the huge rise of data, our traditional systems are not able to handle all such data, both in terms of processing as well as in terms of storage. For that, Google, all of the researchers had worked on this problem. So Hadoop published Google published a paper based on a white paper. They proposed two things. One we called as GFS, that stands for Google File System, and another was the processing engine, which we called as MapReduce. But this GFS, this was quite proprietary. So what happened after that? Yahoo took the initiative and Yahoo made this Hadoop. It's an open source software. It's an basically an ecosystem, and most prominently it's composed of two main things. One is the HDFS, which stands for the distributed storage, and another part is the MapReduce. The idea is quite similar to the MapReduce proposed by Google. So for installation of Hadoop, there are various prerequisites. So what are the prerequisites for installation? First is we have to install Java. So for installing Java, the first one command what we have is Java hyphen version. When you will type this Java hyphen version inside your system, it will it will let me show it to you what has happened. I've already This is the way. Java hyphen version. So Java not found. For installing Java, the command is already given: sudo apt hyphen get install open jdk hyphen 8 hyphen jdk. Use control shift and v to paste it. Control c is for cancelling, control v is for cancelling. Okay, this will automatically install the Java. After Java is installed, there are various other steps. As first we will check what sort of Java version we have installed, and besides that, our Java will be installed at this location, user liv jvm. Java is getting installed. See, we will type Java hyphen version, it will give us. Okay, Java is already installed. Move to the current location, user liv jvm, and you can, based on that, when you move to this jvm location, you will get what sort of Java is already installed in the system. So Let me first of all go through the whole of PPT. Later on, we can see how to install it. Okay. Now, when the Java is installed, that means Java is installed and Java will be located at this location. You can check. You can move to this location and Java will be installed. After that, what we have, this is another prerequisite for this thing. So what we since we have to create a special user account for running Hadoop. So for this special creation of this user account, we will use this command sudo su. It will take us to the root. Sudo su will take us to the root. After taking to the root, what we do, we will add an account. What we call it as add hd user. This add hd user. This hd user will be the account for accessing this Hadoop. Since this has been already added, what we will do, we will we will use sudo to this account. Then the command is user mode hyphen a capital G sudo sd user. This will create the newly created sd user account. Besides that, now since the account is already created, we will just move to this account sd user. For that, we will use this command sudo su hd user. It will go to the newly created account hd user. Now after hd user, after the account is created, we have one more thing. We have to install ssh. Now why to install ssh? Since hdfs uses, since Hadoop uses distributed systems, that means it connects to more than one nodes. For connecting more than one nodes, we use ssh, we use ssh server. But before installation of ssh server, what we do, we will purge this package from our Linux system. For that, we use this command sudo apt hyphen get purge open ssh hyphen server. This will remove the open ssh server. Now for installation, we will use this sudo apt hyphen get install open ssh server. That means this will install the ssh server inside this. Now when ssh server has been installed, what happens? Since, as sir has earlier pointed out, the nodes interconnect with each other. That means there are various master nodes and slave nodes. By master node, we have two. That is the most prominently, these are three, but we mostly talk about two. They are the main actors there. One is the job tracker, another is the name node. Name node maintains the file system, and uh, uh, pro, job tracker maintains the job. Okay, how well is the job being performed by the nodes? Besides that, there are slave services, various. There are most prominently there are two. One is the data node, another is the this uh, task tracker. Data node has the actual file location, and task tracker are the actual worker nodes which process the data. So for that, what we do, uh, when these nodes communicate with each other, they pass for authentication purposes. They pass keys within each other. For passing keys, what we will do, we will use this command ssh hyphen keygen hyphen t rsa. That means they are encrypted by rsa algorithm. After that, what we use an cat command, and we paste this command in the terminal. Hello, hello. Okay, we have to paste this command inside that. Now, since this SSH is already installed, what we will do, we will just go to the SSH localhost. That means it will check, okay, whether this is installed properly or not. Now comes the main part, which is downloading and extracting of Hadoop. So for downloading and extracting Hadoop, what we will do, we will go to the, we will first of all go to the newly created SD user account. For that, what we have, we will use this command: change directory to slash home to SD user. It will go to the newly created user for this Hadoop. Now, after that, what we'll do, we will use a wget command. This will download this file from the internet. I will show you how to do it. When it has been downloaded, use ls gives all of the contents inside a directory. Use ls to verify whether the download has been there or not. After downloading, what we have, Hadoop, what we will download the latest version. After downloading, we will use this command sudo tar, this command sudo tar xvf Hadoop, this one. This will extract the Hadoop. uh, okay, now the Hadoop is extracted in the SD user directory. What we will do, we will move this location, we'll move this location to this to this. We will move this newly created this newly extracted file Hadoop, this one, to this command, to slash opt. Now there is a specific reason we are moving to this, which I will come later, which I will come later on. So when this has been moved, you can just go to that command, go to that slash opt. You can verify whether this has moved successfully or not by using cd slash opt and ls to verify it. Now after finishing that, what we will do, we will go to the root. For going to the root, we will use cd slash opt, and these are the same procedures which I told you to move to opt. Now after this, we have moved our this extracted file to the opt. We will change, sudo gives privilege, we will use chmod, change mode 77 means read, write and execute. This command we will use uh, with this extracted file. After that, we will go to the root by using this cd slash. That means this Hadoop has been extracted and downloaded successfully. Now after that, what we have to do, since we have already installed this Java and all other files, what we have to do, we have to update various files. Now what we have to update, we will go to the this newly created SD user directory. We will move with this thing, cd slash home to SD user. Now after that, what we will do, we have to update the various configuration files. So for updating the various configuration files, what we will do, we will use this command sudo gedit dot gedit space dot bash rc. What it will do, sometimes this gedit does not work. So for that, we can also use nano, sudo nano dot bash rc. Okay. When this file gets open, paste the following lines at the end. Paste these lines: export Java home is equal to this thing, this. All that paste you have to paste it at the end. When you will paste it at the end, you can see our Java was where JDK was there. It was in the user lib jvm. That means this only is the path. This only we have the path of these files. So you are just pasting what you have already installed. What are the current locations, you are pasting inside this bash rc file. Use copy it, paste it. Either you can directly paste it with the cursor, or you can use control shift and v. Don't use control c. Then you can this, for updation you can use control x, and then yes, to make sure that okay, this already has been updated. Now after this bash rc file is updated, what we have also other thing. See, I have already written it inside this. After pasting the lines and use control plus x and then use y and close the file. That means the file has been updated. Now just type the command source.bash rc in the file. You are in the same hd user directory. Now when you will use echo dollar Hadoop home, it will give the location of the Hadoop. The location of the Hadoop is slash opt lib jvm, like that. If it prints, that means your bash rc file has been updated. Now go to the root and go to the options, go to cd opt folder. Now what we have to do, what we will check what sort of Hadoop files are inside this newly created this Hadoop. We will just move to this location cd slash Hadoop, like this thing, slash etc slash Hadoop, and then use ls. It will list all of the files inside the Hadoop. Now for when we will list all of the files, we have to update various configuration files of Hadoop. So for that, what we will use, we can use sudo nano or sudo gedit. Sudo gedit hadoop env dot sh. In this file, what we will do, there will be a path of the Java. So what we will do, we will just comment that file. We will comment that part and append the and sorry, just I think this Linux. Just a minute. Okay, this I think there is a just I don't think this is working properly. Let me see what delete. Sorry. Okay, okay, if, now what we have to update various files. We have already I have already told you to export and to comment this Java line. Now what we have to do, since our Java is at this location, user lib jvm, this Java, this version we have already installed, paste it there. paste Paste this export.gav dot, paste this in the at the end, below this export Java file, and paste it and save the file. This is env.sh. After that, what we have to also go to other files. That means sudo nano or gedit you can use. We can go to the core hyphen site dot xml command. We will paste these lines, we will paste these things inside this command. See what we have. We have this file system default name is hdfs. This will be the location. When you will run this, when after Hadoop is already installed, you will just go to this link in your browser. It will open this hdfs inside your system. It's all, you can all get it very smoothly. Besides this thing, Hadoop also creates a number of directories. So you have to paste these things inside this file, nanocoresite.xml. Copy these lines in there will be a configuration, this configuration tag. You can paste it in the configuration tab, save it and cancel it. Other file, what we have to do, we have to see, this is one of the most important file, which is hdfs site.xml. Now paste these lines in the configuration tab. See, sir has already told you, since Hadoop is an distributed file storage, what happens there, Hadoop has high Hadoop is highly reliable, Hadoop is highly available. So for that we can set the replication factor. Because consider a Hadoop with 100 nodes. So it's not very well if you just use the replication factor of 1, because if the node getting down is inevitable. So for handling that, what we can configure this parameter, dfs dot replication. That means it will tell you how many replicas of the file you.
Me-
Yes sir.
just a minute, as a point in clarification, because this point what Meet told, the nodes getting down is inevitable. Just a small note on this. Traditionally Hadoop was the way, the motivation with which it started was that they wanted to build from commodity hardware, means hardware which are not very high end, already there in use, maybe not so efficient. So those sort of almost discarded hard disks were used for building up those storage servers. So that is the reason, I mean, you can assume, I mean, this was the original motivation. You might install Hadoop on a very high-end storage facility. That doesn't change the, that can't change the motivation with which it started. So that's a small clarification. Yeah, please go ahead. Thank you.
Just a minute.
Yeah, please continue, Mir.
Just a minute. So for that, you are configuring various parameters inside its configuration files. What has happened? So, okay, this one. Yes, this one. Yes. Listing. This is fine. Core site.xml. This has been already told. Okay, this one. Yes. Okay. Inside this SDFS site.xml, you will configure this
Mir, your audio went off or what? You're there, Mir? We'll just wait. Otherwise, if he has lost connection, then I'll continue. Just let me see if he's still there. Just try to call him over phone. Mir, you have lost connection. No problem. I thought I'll just normally. Yeah, I think his connection has got dropped. So no issue. I'll just continue. Let him as and when he joined. Just we'll see if he can join in a minute.
Sorry, I have just lost my connection.
Okay. Okay.
My
So you're back.
because of the internet is little bit slow.
No issue. You carry on. If any
Okay.
problem, just let me know. Even if I'm not here, Moya can. In that case, if Mir loses connection, you can just tell me. I'll be back and I'll continue from the performance optimization part. Okay?
Yes, yes. That means for SDFS site.xml, you will configure these parameters, replication and the name node and data node directories. You will paste these lines above, save it and cancel it. After finishing this SDFS site.xml, you will configure this yarn site.xml. So for that, what we will do, we will this we will paste such lines inside this the yarn site.xml. uh, After finishing that, what we will do, we will use this command. We have to create a file called mapreduce-site.xml, but the contents of this mapreduce.site.xml, these contents are already in the this mapreduce.site.xml.template. What we will do, we will use this command sudo cp means copy. It will copy the template into this file. This command will copy contents of the template file into example. Use ls to confirm whether MapReduce file has been this created or not. That means this will be the final the final file to update is that MapReduce site.xml. For that, what we will do, we will use sudo nano MapReduce site.xml. We will paste these lines inside the We will paste these lines inside this configuration tag in the mapreduce site.xml. And finally, that means you have configured all the Hadoop files. Now the Hadoop configuration files have already been configured. Now what is the other thing? There are just 4 or 5 steps left for Hadoop installation. For installing Hadoop, what we will do, we will just go, since we are in the this OPT folder or Hadoop folder, we will just move to the HD user, our newly created account for Hadoop. By this command, we will just move to the Hadoop, this HD user command. Now, as I earlier pointed out, this Hadoop creates directories, name node directory and data node directory. So for creating that directories, which we already see in the configuration files. So for that commands, for that we use these commands: sudo mkdir hyphen p hadoop underscore tmp temp hdfs name node. This will create a directory for name node, and this another command will create a directory for data node. So since the directories are already created, what we will do, we will change the mode. That means we will change the, by using this sudo change mode 777 within this, for both name node as well as data node. Now mostly what we will do, we mostly operate with data node. What we have to do, we will give privilege to the HD user. Okay, you will be the owner of this direct newly created directory. So for that, what we use, sudo ch means change owner hyphen r hd user. This command will be used for changing the owner of this data node. That means we have set up all the configuration file. Now is the final step. Now for final setup, what we will do, we will paste this command: sgfs name node hyphen format. This will format the newly created name node. And for running various daemons means various processes which run in Hadoop. So for running this hdfs, we use this command: start hyphen dfs.sh. Dfs stands for distributed file system. It will start the dfs. And for starting the map reduce, we will use yarn.sh. Start hyphen yarn dot sh. It will start all of the daemons for MapReduce, that is node manager, various things, like node manager and all. And for seeing what sort of processes are running currently in the system, we will use jps. Jps stands for Java processes. For for if the Hadoop is successfully installed, all such processes will be running. That means node manager, resource manager will be for this yarn.sh, and data node secondary name node will be for this dfs. That means if it runs successfully, that means Hadoop has been successfully installed in your single node setup. Now open these two links: localhost, you paste these lines into your browser, you will get the resource manager, and you will paste this line in the browser, you will get the name node.
Sir, sorry to interrupt. Actually, your screen is not shared, I think.
I think I've already shared it. Actually,
Since you have reconnected,
okay. Sorry. Present now. Okay, just a minute. Your entire. Okay, I'm sorry. Sorry. Thank you for letting me know. Thank you for letting me know. Let me backtrack later. Okay, is it fine right now? Hello.
yes, sir, we could see.
Okay. Is it fine? Okay. That means you have
Yes,
to
sir.
set up, you have to set up all of the Hadoop configuration files. Now, after the Hadoop configuration files are set up, what we will do? We will use this command to go to the newly created. We will use this cd slash home slash sd user to go to the newly created Hadoop account, and we will make directories for Hadoop. For making directories, we will use this command: mkdir sudo mkdir, one for name node, one for data node. Further, now what we will do, we will change the mode of these newly created directories. Sudo chmod, because SD user has to take control of it. So what 77 means: read, write, and execute, both for name node, both for data node. Primarily, what I said is that data node, mostly we work on data node because we stored the file into the data node. So for what we will do, that we will change the owner of this directory. So for that we use this command: sudo change owner -r hd user, this thing. This will change the uh, this uh, this will change the owner of this directory, newly created directory, data node directory. Now is the final step. In the final step, what we will do, the first command is you will type this line into your this thing, into the terminal: hdfs name node hyphen format. This will format the name node successfully. Now after the name node is successfully formatted, what we will do, we will start this daemon: start hyphen dfs dot sh. What is this meant for? This is meant for, this will start the hdfs inside your nodes. DFS stands for distributed file system. Now for running MapReduce, because sir has already told that Hadoop is an ecosystem. Since ecosystem, sir has focused on 2 points. One is the distributed file system, which is the hdfs. For running that, we use this command. And sir said another thing, that is the MapReduce. So MapReduce had some limitations. So what we are using right now is yarn, yarn. So for running that, we will for processing, we will have to start hyphen yarn dot sh. These will run various background processes inside your system. So for getting what sort of Java processes are running, we will use this command jps. If it's working fine, it will show all of the Java processes. Right now, the Java processes which might be running are node manager, resource manager, data node, and secondary name node. If all of these are running, that means your this installation is fine. Otherwise, if one of them is missing, that means there is some sort of issue, which you can see what's the issue. When all of these are running fine, that means Hadoop has been successfully installed in the system. Now, how to check whether it has been successfully installed or not? You will copy these lines: http localhost hyphen 8088. You will paste this line inside your browser. It will show the resource manager. Resource manager means it gives resources to the cluster. It tells about all of the resources in the cluster: how many nodes you have, how many sort of containers you have. You will get to know all of these. And for seeing, okay, what sort of file system is inside it, we use this command: http slash localhost this 570. When you paste this, you will get name node inside your system. Name node will tell you the status of the file system inside this. That means if you get all of these, that means your Hadoop is successfully installed inside a single cluster, inside a single node. We are not installing it in a means a node 100 nodes. We are just, this installation is only for meant for a single system. For your, if you want to see the Hadoop, you can install it in your single system. Furthermore, now suppose if you have to stop all such processes, always use these two commands: stop hyphen dfs dot sh and stop yarn dot sh. This will stop all of these daemons which are currently running in the processes. Finally, this will, if you look at the resource manager, you will get this snapshot inside your screen. That is this http localhost 8088. It will just, I think it's, the image is quite, it's not possible to uh, to increase the size of it. You will get this thing as an output in your browser. And for resource manager, you will get this for this, no, it's not resource manager, it is your name node. For name node, you will get this information inside this this in your browser. So I have already done it. So let me show it. Let me demonstrate it how to do it. Is it fine right now? Hello? 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 Hello?
Fine, sir. It's fine.
Okay. Let me show it. I had recorded some videos. Let me show it. The installation. Okay. For installing this, let us go. Select. I already. Okay. Just. Is it fine? See, for installing Java, we use this command Java hyphen version. We will just go to the lib.jvm this directory, and we will see okay what sort of is it installed or not. For using that, we will use the ls command. I have already installed it in the system, so I will just use one of the versions, which currently what we are discussing is that one, this one, openjdk hyphen 8. This will be the version which we have used. This will be the version. Make sure you only install that, because we are configuring it. We are configuring it that way. Otherwise, if you have to do some other version, you have to ensure that okay, you have to just update the file there. That's what. Now after this has been installed, what we will do, we will move to the second part. That is we will create a newly account for this Hadoop user. For creating such Hadoop, this we will go to sudo. Okay, for installing, this is for installing OpenJDK. Okay, this I will skip. This is already installed. Now we will create, what we will do, we will create a new Hadoop user for accessing HDFS and MapReduce. For using that, we will use sudo su. It will ask for the password. After giving password, it will take us to the root. Now inside the root, what we will do, we will add a user. We will add any user. Like I have added here, I have added HADACC, Hadoop account. I have created this account. It will ask for new password, and you can just put your password and retype no password. All other fields are not required. Full name, roll number, work phone, home phone, others. These are not required. Is the information? Yes, that will be. That means this is already created. You have created successfully HADACC. Now after that is created, what we will add Hadoop user account to sudo. So for that, we will use this command user mode hyphen aj sudo hd user. It will mm, it will add user account to sudo. That means this has been added. Now go to the sudo su hd user. It will take us to the hd user, currently hd user account. Right now I have used I have not used hd user. I have just used Hadoop ACC. So this, see, you can just check. You can say this newly account has been created, HADACC, because I have used HADACC. Okay, after that, what we will do, we will, that means we have to purge third parties. We have to purge OpenSSH from the system. See, we have purged OpenSSH from the this thing, from our account. Now we will again install this We will again install this OpenSSH server inside the system. This will ask for installation. Okay, the installation is done. After the installation is done, what we will do, we have to generate various keys, because I already told you this is a distributed system. The various nodes communicate with each other. For communication they require various sorts of keys. That is here, for encryption we use RSA algorithm. So I will type the command ssh hyphen keygen hyphen trsa. Okay, this will be automatically saved to the Hadoop account. Nothing, you cannot, you have to just leave it empty. This is the key generated like that. After finishing that, what we will use, we will copy this rsa dot public this key to the set of authorized keys. This is fine. Now we will go to the ssh localhost. Okay, it's fine. One click fine. Are you sure you want to continue? That is fine. After that is fine, that means the prerequisites are fine. That means prerequisites includes your Java installation. Second is that creating an user Hadoop account. Third one is installing SSH server. Based on that, your prerequisites are fine. That means all sorts of prerequisites you have already installed. Now comes the turn of Hadoop. How to install Hadoop? For installing Hadoop, Hadoop, what we will do, we will go to the, okay, just a minute. See, for installing Hadoop, what we will go to the Apache Hadoop. Just put your Apache Hadoop. Apache, you will go inside the Apache Hadoop. You will go for download. You will go to the mirror site. You can see downwards. This will take, and you will download the latest version. Yes, it will take some time. You will go to the top one location. You will just download this Hadoop 2.10.0. Click it. You will go to the blow file tar.gz. Copy it, paste it at the above. Then take the whole link, copy the whole of the link, Control C, and paste it in the this terminal. Use wget, and for pasting the already copied link, you can use Control Shift and V. Control V is not going to work here. Remember, Control Shift for pasting in the this terminal. You have to use Control Shift and V. We'll use wget. We will use wget and we will paste the link. This will automatically download the Hadoop. This is okay. I will skip it. Okay, now see, now Hadoop has already been installed. Just use the ls command to verify, okay, whether it has been successfully downloaded or not. Okay, this is installing. This has been installed. That means, okay, it has been saved. It shows that it has already been saved here. Now let me use the ls command to verify. Okay, this has been already downloaded, tar.gz file. This has been downloaded. Now we will move this location to the, we will extract, yes, we will extract this we will extract this tar file. It will extract the file. It will extract the file. This will extract. After extracting, what we will do, we will move this location. Use ls command. You can see within ls command. You can see, okay, it has already been extracted. Sudo move from here location. That is the home Hadoop account. To what we have to move to options, to slash options. Yes, this we have to move to slash opt. as I earlier pointed out in the this presentation. Just wait a minute. Okay, I have already moved it within OPT. Within OPT, if you use ls, it can be moved. It can be seen that Hadoop has already been moved to that location. Now after finishing that, what we will do, we will we have to we have to I think whether I have created, I mean, I think something. Okay, it has been moved. Okay, we have to change the mode. We have to change the mode. Okay, we change the mode of this Hadoop. Now we have to create various directories. Okay, okay. See. After finishing, I think it, I think 11:30 has already been there. 11:30 has already been. Shall we start? Shall we stop at this time? Hello. 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 Hello.
Yes, sir.
Shall we stop at this time?
Yes. Yeah, I think better we stop right now, Mir. We'll start again at 12 sharp. Okay, so you
Okay.
continue from here. I'll be there.
Okay.
When you want, you can let me know. Yeah.
Okay, sir. Okay, sir.
So we break now.
Okay.
Let us join sharp at 12:30.
12:30. Okay.
Hey,
Okay.
sorry, not 12:30. 12. Sorry,
Okay.
sorry.
12.
I
12.
sleep after.
12. We will again start.
Yeah, we'll start again. And Moya, please stop the recording now.
Okay,
Oh, but then we'll be joining in a different link. No?
Okay. Yes.
Yes.
Yes. Yes. Yes.
Yeah, we
Sir.
will share the link.
It will be easy for Maya to manage, and these all have to be uploaded. So, okay, then we'll break now. We'll please join in the link for corresponding to session 7. Okay. I hope all of you have given your attendances.
Yes, sir. Yes.
Yeah. Please, Maya, please stop the recording.